Hi, I posted a video yesterday about the binomial setting, and my kids and I were playing a dice game where each side of the dice was a different color. And I asked you to explain why this could be used with a binomial distribution.
So I specifically told you that I was interested in rolling a yellow. So this is a binary setting. Either the roll of the dice is yellow or it's not. So we can take care of the B in the acronym BINS. Next, we move into independence. Because this is a dice, there is independence between trials. Each roll is not impacted by the next roll. That's the I in BINS. Next, we look at N. N, you have to have a set number of trials. I specifically told you that I was only going to allow my kids to play this game for 12 turns, so we do have a set N. And then the last variable we have to look at is S in the acronym BINS, and that the success rate is staying the same, and which it is. The success rate is 1 out of 6 that I will roll a yellow, and then that means my failure rate would be a 5 out of 6. With this information, I can proceed.
So now that we've confirmed that the binomial setting can be used, I go to my formula sheet and I write down the formula for using binomial and the probability that x equals 3. Now, if I'm going to use a variable like x, I have to define it. And this is true for any FRQ you might be answering on the AP Stat exam. So I'm also going to write that x is rolling a yellow on the dice. Okay, so we're looking at exactly 3, so I use x equals 3. In my calculator, I'm going to go to binomial PDF. Remember, there's PDF and there's CDF. The P stands for an exact or a precise value, and because I'm using the equal sign, I'm going to use the binomial PDF.
When I fill in the values from the formula sheet, this is what I'm going to write in my paper. Now, the binomial coefficient is that first set of parentheses. 12 trials, 3 successes. Remember, that could be seen in so many different ways. The first 3 trials are successes, the last 3 trials are successes. And so that binomial coefficient calculates just how many ways you can have exactly 3 successes. From there, I can enter all of this into my calculator, again using binomial PDF, and my final answer should be about 19.74%.
Then I altered the question a little bit and I said, what's the probability that I have at least 3 yellows out of the 12 rolls? So what's changing here is that my inequality is it going to be the probability that x is greater than or equal to 3. Now my calculator cannot do this. Okay, probability that x is greater than or equal to 3 successes would mean 3 successes, 4 successes, 5 successes, all the way up to there being 12 successes. So how my calculator will do this is if my inequality statement is a less than or equal to sign. So this means I'm going to have to use the complement. I'm going to have to do the complement of x being greater than or equal to 3, which is going to be that x is actually less than or equal to 2.
So when I take the complement and I look at x being less than or equal to 2, what my calculator is actually adding up is the probability that x is 0, the probability that x is 1 success, and the probability that x is 2 success. Now, thankfully, when I use CDF, the calculator will do all of that math for me, so I don't have to calculate all those different scenarios, and I end up with a probability of about 32.26%.
Then I extended the question one final time and I took it out of the binomial setting altogether, and I asked you to analyze the probability that your first success, so we're now no longer working under a set number of trials, I'm just analyzing my very first success. So our first success is on the 3rd roll. This is actually geometric.
So when I break down this idea, I realize that my first roll is not yellow, which is 5 out of 6 chance. My second roll is also not yellow, which is 5 out of 6 chance. My third roll, I finally get a yellow, which is a 1 out of 6 chance. So I'm going to multiply all these probabilities, 5 out of 6 and 5 out of 6 and 1 out of 6, and I get about 11.57%.
I hope this was helpful for your review for the AP Stat exam. Good luck taking the test.